This chapter is called Process Control. We will begin it by finding out what a process actually is, and then the rest of the chapter will be devoted to finding out how to control such processes. Let's begin. The first question that we have to ask ourselves is, what is a process? A process running program. And I want to put special emphasis on the word running. To understand this a little better, let's take a typical program, say ls, and on a given Unix system of, say, 100 users logged in simultaneously, perhaps 5 of them might be simultaneously running the ls program. So the question is this: how many ls programs are there on that Unix system? And there's only one. There's only ever one ls program on a typical Unix system. However, because 5 particular users are running the ls program at any given moment, that means that there are 5 ls processes running on the Unix system. So to summarize, there is one ls program, and in this particular example there are 5 ls processes. For a program to become a process, it is simply loaded into memory by the operating system and started. While it is running, it is known as a process, and when it's finished, it is no longer a process, but the single program is still there. Every process on the Unix system, in other words every running program, is assigned a unique process ID. Sometimes these are also known as PIDs, or just PIDs, and they typically have a numeric value in the range 1 to 30,000. So if I run a particular program starting a process, and that process is assigned a process ID of 20,000, for example, then the next one I start might be assigned 20,001, or perhaps somebody else might jump in just ahead of me and grab 20,001, and I might end up with 20,002. Eventually you're going to get to the end and you're going to have process number 30,000 running. So what happens when the next one wants to start? Well, theoretically all 30,000 processes are not still running on the system. Some of them must have finished by now. So there will be some free or empty available process IDs that can be used by the 30,001st process. This implies that there is a maximum of 30,000 processes that can run simultaneously on any given system. However, this number can change from one system to the next. So, to get down to practicalities, we can actually examine all the processes that are running on a given system by using the ps command. If you type in ps by itself, it will show you the processes that are running just for the current login session. So let's have a look at that. Okay, so I simply type in ps and press enter, and I find that I have 2 processes running at the time that ps was invoked. One is my shell, bash. Notice the 4th column, that's where you'll find the name of the program. And I also have the ps program running, which is pretty typical. Whenever you use the ps program to list all the running processes, you'll find that at the time ps is naturally one of those running processes. So you might think to yourself, well, okay, ps sounds like a pretty boring and useless program. Obviously the only programs I'm ever going to have running when I run the ps command are my shell and the ps command. But there is actually a whole lot more to it than that, and let's have a look at that now. ps can be used with the following command line options. You can specify the -u option. If you specify -u followed by a username, it will display all the processes for the given user. Then there's the -f or -l options, which both display the regular listing, in other words, just the processes for the current login session, but it displays them with more detail. And there's 2 basically different types of long listings. The -f listing will give you a different set of details to the -l listing. And then there's the -e option, which displays every single running process on the system. And naturally there can be quite a lot of them. All of these options can be used in conjunction with each other. Well, you can't really use the -e option and the -u option together, but you can use -e with -f, or -e with -l, or u with f, and so on. Let's have a look at some of that right now. We'll start with, say, the -f option, ps -f. gives us essentially the same information, but it gives us some extra details. Now, I didn't actually mention what those details actually are. The first one, so we'll go back up here to the original PS command, and we'll find out that this is our process ID, this is our unique number in the range 1 to 30,000, often known as our PID. So I've got 16,029 as the process ID for my shell, for example. Notice that that is the same process ID still hasn't changed. The process is still running with the same process ID, but the PS is different to this PS. This was 16,378 and this one 16,490. So in the intervening time, 112 programs have been started. Or should I be more precise, 112 processes have been started. Anyway, other columns involve TTY, that's the terminal that you're running the process on, and the amount of CPU time in seconds that that process has used up. That will enable you to determine how much of a load your programs are placing on the system. The extra columns that you get with the -F command include the PPID, which is the parent process ID, or if you like, the process ID of the process that started this particular process. The PS command is 16490 was started by 1629, and 1629 is the shell. So the shell started the PS, which is what you would expect. The shell, incidentally, was started by process 16028, and we don't know what that process is because it's not part of this list. I'm not sure what the C column is for. S time that the process was started, again the TTY, and again the time, and then now the command is given with its full command line options, PS-F. So there's a subtle difference between this column here command and this column here command. You get the command line options here, but here you don't. And the little minus sign there simply indicates that this is a login shell as opposed to a shell you might have started manually. Let's have a look at PS-L. You get a completely different set of information, and to be honest, I don't know what a lot of these things are. I don't know what F is, I don't know what S is. UID, well, that's the same as mVirtue, just displayed as a number. So my user ID on this system is 3040, always was, always will be. Again, the parent and current running process IDs. I don't know what C is, I don't know what PRI is, I don't know what NI is, I don't know what ADDR or SZ or WCHAN are, and the rest we know. Now we could use the PS-U command to find out all the processes for a given user. Let's find a list of users using the WHO command. So we could now say, choose one of them. We could say PS-U, and we could choose the user, let's say S-A-R-T-O-R-I, Sartori. I have no idea who that person is, but I'd like to see what they're doing. Okay, well they're running a couple of shells, a couple of bash shells. They're also running 3 copies of the program called BitchX, whatever that is, and LFTP. LFTP is not associated with a terminal. If you don't know what that means, don't worry. We could also use the -F option in there as well, PS-FU, S-A-R-T-O-R-I, and we get the same details, but we get some more information. So we could see, if you like, the command line for those BitchX programs. Finally, I'll do a PS-E to find out all of the processes that are running on the system, and they're all scrolling past now, and there's quite a lot of them. I might do that again, PS-E, and this time I'll pipe the results to WC-L to find out exactly how many processes are running on the system, including, of course, the PS-E and the WC-L, and we find that there are 209. Okay, so, and then you can use that with grep, for example, if you need to find out all of the people that are running, say, Vi. So you might do PS-E, pipe to grep Vi, and it'll show you only the ones that have the word Vi on the list, which is following. And there's just 2 of them. I didn't use the F command, so I can't find out who they are, but I can see what terminal they're on, and their process ID and so on. But getting back to just the basic PS, if I just type in PS like that, you might think to yourself, well, it is simply not possible to see anything other than your regular shell and the PS command if you type PS on the command line. In other words, you might think it's not possible to start any other programs at the same time. Well, I think if you recall that Sartori fellow, whoever that was, they had several programs going simultaneously. I wonder how they did that. Well, I'm going to show you in the next module how to start programs simultaneously, but what I will show you at the moment is, let's say I open up the program called Vi. We'll be learning about Vi in the next chapter. It is our text editor, and I will use it to edit a particular file, let's say another.txt. Okay, so we're now in the middle of editing that particular file. Now, would it be fair to say that in this current terminal session at the moment I am running a shell and I'm also running Vi? So if I was to do a PS at this point, which I can't do, I would find that I have running the shell and Vi, and of course I would also find that I was running the PS command. Now, this is something that you won't know about because you haven't seen Vi before, but it is possible within Vi to actually call up another shell. If I type in :sh in Vi, it actually starts for me another shell. And here I am now running another shell. So what's actually happening here is I've got my original shell running, and then I've used that to start Vi. And then within Vi, I've actually temporarily suspended Vi. Well, Vi is still running, but I've actually obtained another shell. I haven't dropped back out to my original shell. I've got a second shell running. And if I use that shell to run the PS command, I can prove that all of that is true. Now you can see that I'm running a bash, followed by Vi, followed by bash, followed by PS. And if I use the PS -f command, I can use their parent process IDs to trace the fact that the PS was started by this bash, and this bash was started by this Vi, and this Vi was started by this shell. Well, they were all started by me, but that's the way the processes created themselves. Now, of course, when I exit this particular shell, I drop back into Vi, and if I quit out of Vi, then I drop back into my original shell. I'll show you a little diagram of how I like to think of that. It's useful to think of this as a process stack. You start with your basic shell, which is the shell that you log into, and then you use that shell to start another program, say Vi, and the way you think of it is that you load Vi in on top of the shell. Now, you only are interacting with Vi at this point. The shell is still running, but it's kind of on hold while you're interacting with Vi. Then, as I showed you in the last example, I can use Vi to start another shell, which is loaded on top, and so temporarily Vi is put on hold while I interact with the shell that I've just used it to start. And then in that particular shell, I can say, run the PS command. When the PS command finishes, I'm back at my original shell, then I typed in exit to that shell, and that shell went away, and I was left with Vi. And when I decided to end Vi, that went away, and I was left back with my original shell. Incidentally, if I got rid of that as well by typing exit, then I'll be left with no processes, and I would be back to a login prompt. But the way that these processes are loaded on and taken off is very, very similar to a stack, like a stack of books or a stack of boxes. You load them on top and then you take them off. You can't pull ones out from underneath. You're always interacting with the top one. That's why the term stack is actually a technical computer term, and it is used in this sense quite well.